Hey guys, welcome back to Help a Function. In this video, we are going to discuss another popular interview question, missing number. So the problem states that we are given with an array of size n and the range of the array elements are from 0 to n and every element in the array is distinct. Thus this total range constitutes of n plus 1 numbers, but because we have an array of size n, any one number is going to be missing in this array. For example, let's say n is 3 and the array elements are 0, 1, 3. Thus we see that the range of the array elements are from 0 to n, that is 0 to 3, but one number is missing. Here 2 is missing and thus we need to return 2 as our answer. For another example, let's say this time n is 4 and the array elements are 1, 2, 3, 4. So this time from the range 0 to 4, 0 is missing and thus we will be returning 0 as our answer. So let's see how we are going to solve it. So in this example, n is 4 and the array elements are 0, 1, 4, 2. Now this problem can be solved easily if we take extra space. Let's say we take an array of size n plus 1 and this array is of bool type which is initialized to false. So what we will do is we will traverse through this array elements and every time we get a number, we make it true in our bool array. So a of 0 will be true, a of 1 becomes true, a of 4 becomes true, and at last a of 2 becomes true. So now what we will do is we will traverse through 0 to n and anytime we get that array of this is false, array of I is false, so this I will be my missing number and we will return I as our answer. So in this example, when we will come to 3, we will see that a of 3 is false and thus we will return 3 as our answer. But here we are using extra space, thus our space complexity is order of n. And the main challenge is to solve this problem in constant space complexity, that is order of 1. So let's see how we are going to do it. So we will be using bitwise XOR operation to solve this problem. Now if you don't know what a XOR operation is, XOR of same bits gives 0 and the XOR operation between different bits gives 1. That is 0, 1 and 1 and 0 will give 1 while 0, 0 and 1, 1 gives 0. Now this makes sense because XOR of same numbers is 0. So if we do 5 XOR 5, we will get 0. Why? Because 5 can be represented as 1, 0, 1, and if we XOR it again with 5, that is 1, 0, 1, then we will see that all bits are similar and we know that similar bits gives 0 in a XOR operation. So how can this help in order to solve this problem? So we know that the array elements are from the range 0 to n. So if we XOR these total numbers with again 0 to n, every number which is 2 times will cancel out each other, but the only number that will be left is the missing number. Let's try and understand with example. So we have this array elements 0, 1, 4, 2. 1, 4, 2. We are going to XOR it with 0, 1, 2, 3, 4, that is 0 to 4. And this is the array elements we have. So now if we XOR all of these, 0 will cancel out with 0, 1 will cancel out with 1, 4 will cancel out with 4, 2 will cancel out with 2, and what will remain is the missing number. Thus we will return 3 as our answer. Let's see another example. Let's say n is 5 this time and the array elements are 0, 1, 3, 4 and 5. Thus 2 is missing here. So we will XOR it with 0 to 5, that is we will XOR it with 0, 1, 2, 3, 4 and 5. So again 0 will be cancelled out, 1 will be cancelled out, 3, 4, 5 will be cancelled out respectively, and what will remain is 2. So this is how we are going to solve this problem. The space complexity here is order of 1 because we are not using any extra space, and the time complexity is order of n because we are using a single traversal. Now let's quickly look at the code. We are given with the nums vector, we declare an integer answer which is initialized to 0 and which will be our answer. So now we need to XOR it with 0 to n and also with array elements. So We can have two loops for that. First we will XOR all the array elements and then we will XOR it with 0 to n. But we can do it in single loop as well. We note that this index is from 0 to n minus 1. That is, I will be traversing through 0 to n minus 1. And we XOR it with nums of I, that is, we have XORed it with all the array elements as well. So now, after the end of this loop, we have XOR our elements with 0 to n minus 1 and all the array elements. So what is left is only n. That is, of the range 0 to n, we have XORed it with 0 to n minus 1 and only n is left. So when we come out of this loop, we will XOR it with n, and finally what will remain is the missing number, which will be our answer. So this was all about the problem. I put the problem link in the description so you can go and solve it. If any doubts or suggestions, you can write in the comment, and if not subscribed to the channel yet, then please do that. Thank you so much for watching.